Welcome to everyone from Team JAVAB. It was a time when the world started experiencing deadly disasters. Many scholars from all over the world put forward the views that the earth might not be self-sufficient for the development of the mankind. The deadly signs from the nature and a number of possible attractions from the outer space made it clear that it was time for the Homo sapiens to become multiplanetary species. The word multiplanetary species brought new fantasies to the mankind, and many efforts from all over the world were started to turn those fantasies into reality. The Apollo 11 mission to the moon was a remarkable moment in the history of mankind, which brought hopes in many livelihoods that one day space colonization would become a reality. From that moment to the present day, the efforts for space colonization has steadily increased, leading to the unite expectation of the world power towards a common goal, that is space colonization. When the world started to think of space colonization, two main ideas were born. One of them, which was widely brought into existence by the public, was to colonize on a naturally occurring independent celestial body. In the beginning, this idea was widely accepted, and even today it is considered to be a widely accepted idea. But some enlightened thinkers and scientists expressed their views that any other naturally occurring celestial body could be prone to many natural disasters, and mainly it was very difficult to search for one more option in this case. As a result of the birth of many such questions, the idea of space settlement was born. The idea of space settlement was to construct an independent artificial life sustainable habitat in space. And our efforts to the development of such a future is our project JAVAB. The name JAVAB is a word in the Hindi language which means answer, and as the name suggests, we proudly present our project as the answer to the questions that we have encountered when we thought of space settlement. The structure of JAVAB is mainly made up of custom designed tori, cylinders and cones. This structure has its own set of advantages and disadvantages, where the advantages outlook the disadvantages. The major advantage is that each part is self-controlled and the wastage of its area is minimized, whereas its major disadvantage is that it is a very complex design and is difficult to construct. The external structure of this torus is designed by keeping in mind to reduce the area required for tiling and flooring, and it is also easier to construct this type of torus as compared to the normal torus, as we can observe in the cross-sectional view that the trapezoid torus has only 6 sides, which makes it easier to construct. The parts related to the trapezoid torus are shown in the image. The smart glass has a special capability of being able to control the amount of light passing through it, and the common area component is the common meeting point of the torus and the central cylinder. The smart solar set is made up of 2 layers of solar panels, with the outer one as transparent and the inner one as opaque, leading to the maximum yield of power. The industrial cone structure is made up of cones particularly, and is used as an industrial place, due to which it got its name. The supporter acts as a clamp for each cone. The cone is a place where all the industries and firms will be set up. The industrial joiner joins the base plate to the common area component. The base plate is the place where all the people can meet for seminars, cafeteria, etc. The rotational unit helps each cone to rotate individually. The function of common area component here is same as its function in trapezoid torus. It means that this structure contains 10-sided structure called functional unit, and 8 functional units would be placed in the shape of an octagon. The communication industry would be placed in the communicational structures. The functional units are exclusively maintained for agriculture and animal husbandry. The torus joiners are used for joining the common area components to the functional units. The common area components act as an common entrance to the different parts of the deductor torus. Functional joiners are the structures which join two functional units together. The functional unit is made up of 10 sites and there are 8 such units. Out of them, 4 will be used for agriculture and the other 4 will be used for animal husbandry. The ALA or atmospheric life-abled area is a place where plants or animals will be grown. The storage area is also used as a warehouse. The control unit is a place where all the functional systems of the functional units will be placed. The TAT or thrusters and asteroid traveler are present on both sides of the central cylinder. They are used for both catching the asteroids and also act as thrusters for the settlement. This image shows the paths of a TAT. There will be two TATs attached to two sides of the ends of the central cylinder. This image shows the way in which the TATs would capture an asteroid. The docking section is a place which connects the outer space to the settlement. It is the only entrance to the settlement from the outer space. There are two docking sections for the settlement. The parts of the docking sections are mentioned in the image shown. The transport section is a major part of the docking section. It consists of a protection cover and a runway. The protection cover protects the contact of the vacuum in the outer space with the settlement's atmosphere. This image shows the dimensions of the trapezoid torus of a cross-sectional view. The total area available for the residential purpose in the two trapezoid torus combined is 2.2 km square. The dimensions of the ICS is shown in these images. Each cone has a surface area of 0.11 km square and there are 12 cones in two ICS combined with 1.32 km square of usable area. The dimensions of the base plate is shown on the screen. These are the dimensions of the deck octatorus. The dimensions of the functional unit is shown in this image. These are the dimensions of the docking section. These are the dimensions of each TAT. The image shown on screen shows the dimensions of the central cylinder. This image shows the lateral dimension of the complete settlement. The first step in the construction sequence is the construction of the central cylinder. After that, the TATs will be positioned. Then the docking sections will be built. After that, the common area components of different parts will be arranged. Then the joining structures will be constructed. After that, the ICS and the trapezoid torus will be built. Then finally, the deck octatorus will be built. This image shows the complete construction sequence on a single screen. There would be bases set up on Moon, Mars and Earth known as FAM bases or foldable and movable bases. The image shown is a base on Moon. As the name suggests, they can fold and move across the land. This part is known as foldable runway and is used as a runway for space vehicles. This part is known as hybrid solar cell as it can change its direction for maximum output and can move to new places in search of sunlight. These are self-controlled and do not need human intervention. This vehicle is known as Central Controlling Vehicle, which takes care of the functioning of the entire base. This part extends its communication to different settlements. This is the interior of the living area of the employees working in the bases. The total budget of this project is 156,248,462,494 dollars. The construction of the settlement would require 26 years. This is a project JAVAB from AV Sai Santosh, the team captain, SG Sridevika, team member, Shashank Gowda S, team member, and this is our project JAVAB. Thank you everyone for spending your valuable time for our project.